Alright, and we should be live. Let's see. YouTube. YouTube we are go. How about Twitch? Where will we start this? There we go. Okay. What? My younger brother is informing me there's a lion eating my door. Let's clear our notifications on this. I'm streaming right now, so please don't bang on my door. Arthur, please don't mess with my door right now. I'm working. Little brothers are fun. Okay. So, what are we working on today? Basically, right where we left off yesterday. Not yesterday. Last stream. And last stream, what I decided is, out of all the different things that I could do, I'm not going to do any of them. Instead, we're going to start working on an interactive console, like CLI, for BraneScript. Similar-ish to like the Python or Elixir interactive command prompts. Or I guess maybe the JavaScript console as well, but it's going to be slightly more managerial than that. You're not just going to be typing code in, you're going to be doing actual commands, and as part of those commands, you'll be able to run code. So maybe closer to GDB. GDB would be like a better example, but it's like the language itself is its own development, its own console. So if I just cargo run this real fast, you'll see what it's looking like right now. I also did fix the Windows compiler errors. And I did that by not fixing them, but instead by switching to the GNU tool chain. So we're not using MSVC anymore because its linker started breaking, which is fun. But yeah, so now we have an interactive CLI that doesn't do anything yet, but I can call build. Let's try example scripts. And then, what was my test code loading before? Test function. Example scripts. Just do test bscript. Hello. Oh, Squarepeg, I haven't seen you in a little bit. Oh no. Okay, not yet implemented. We don't do that here. So maybe it was load. Load that does stuff. I don't know. Recognized subcommand. Interesting. Why is it just stuck on that command? It should have flushed it by now. is it acting that way? The standard in, read line. This isn't... This isn't necessarily doing anything. Do the commands still work? No, it's like standard input is just... Or I might know what's going on. We're gonna split args. Is this a string reference? Okay, it is, which means we can just do this. Do 0 to... If it's not reducing the size of this input string, it's just using it like a raw buffer, then we might actually need this input length to concatenate it. Unless it's concatenating onto the end of the string, it could be interesting. I don't know. I haven't had problems with this CLI like that before, but let's try doing that again. I'm gonna try triggering the same error. Wait a second. This to-do should have crashed the entire program. No, wait, it did last time. So, what did I do? Anyways, build... Okay. Unrecognized subcommand. Example scripts test bscript. If I type help now, it gives me all the help commands. So yeah, we're not getting the same issue we had before. Error unrecognized subcommand examples. Usage build command. Ah. I'm just going to do that real fast because that might be our issue. I haven't used the CLI too much yet, so I'm not super sure how it works with this. I'm gonna get on. Let's see. Almost 10 minutes ago is when I started streaming, so not too long ago. All right, let's try this again. Build example scripts test bscript, which will fail. And then okay. Yes. So I think that was the same order of commands that caused that bug to show up. So let's try loading. Try loading module test, actually. Why did I search for that? Okay, so it is without an equal sign. So load module test, example, scripts, test, bscript. Unexpected argument, module found, load command. Maybe that. Interesting that, wait a second. Is my string splitting split? No. String splitting works fine. What animal is your avatar? It is an Avali. So not necessarily anything specific. It's kind of a feathered raptor. Here, I'm gonna print out a little bit of debug info for now. Just since we're not sure stuff is actually working yet. One thing I might need to account for is I believe clap is used to disregarding the first argument. So we might need to insert in a placeholder argument where the executable would usually go. Maybe. Unless, let's see. Let's look at the definition of parse from args. Or parse from environment. We just call parse. This will so this instantiates the command, and then we get matches from environment arg os. First argument is traditionally the path of the executable, but it can be sent to arbitrary text, even though that might not be. This means this property should not be relied on for security purposes. Yeah. We get matches from try get matches from mutable. Nah. We have a cursor. Extracts the portions of the file before. Interesting. Oh. Where an external hard drive randomly disconnects and reconnects, and on the different, I just had my monitors randomly disappear, and I was like wondering why it did that, but I just had the external hard drive disconnect, and it caused the monitors to disappear. So I'm wondering if just disconnecting the external hard drive, we just disconnect the external hard drive, does that fix, well, that will stop it from randomly disconnecting and reconnecting for sure, but there we go. I am now far away from my camera. There we go. Get the cool framing back. Okay. Headphones. I have to set up my displays again. See, I'm currently studying data structures and algorithms. How often do you use linked lists, sorting algorithms in your coding? And do you think they're important to the average developer? So, to the average developer in the modern day, you pretty much never run into like a raw linked list. Now, there's other data structures that use linked list concepts internally, and there's a lot of kind of operated, like a lot of C APIs and driver software do use like linked lists. Like a good example I can think of is in OpenXR, when you're initializing a session, you need to provide context structs about what extensions you want, like the settings of those extensions, and you pass those extensions in as a linked list. But like the vast majority of developers aren't going to be interacting with systems. They're not going to be interacting with systems like that. If you're just like a web dev, if you're working in like C, you'll probably run into them. Like not a ton, but you'll run into them, and mostly not of your own making. But nowadays, you try to avoid linked lists because they're not great for CPU caches. While they are faster on insertion and deletion of elements, from a purely algorithmic standpoint, a lot of times just the cost of like not being able to go to a specific element is worth it. Now, I'm using something similar to a linked list in like an entity component system that I wrote, and soon we'll be using them in once we actually write like an allocator here, because I'm going to be paginating, like have paginated data structures, and paginated data structures are kind of a linked list because you have this list made out of chunks of separate memory allocated in different sections, and that looks visually similar, but a lot of times the references to those different sections of memory are stored in a contiguous array. So it's not really a linked list. It's just kind of like it's a linked to list. No, I'm reaching a little bit here. So short answer, no, I don't really use linked lists basically ever in my own code. But if you're interacting with driver code that's like driver code, you will run into linked lists a fair bit. Okay, what was I doing before all my monitors disappeared? Right, I was adding debugging info to args were split into this. Input this was split into that. So now we'll be able to see the input into our command line and what we're reading that input as, and that will tell us why the command line randomly stops hearing new things. Because this, if I'm understanding it correctly, should just work. Any other data structures? You mean B trees, node structures? I use node structures a ton. Binary trees less so. I haven't run into a use case where I've needed to use a binary tree yet. Maybe soon as I start getting into like once I start working on actual game engine stuff and have to do like segment things spatially, B trees might be good for that. But yeah, I use node structures a ton. A good example I can show you right away is in, well, both my compiler and intermediate representation are stored as a little bit of a node tree. I mean, I guess it's really just like nested data structures, like, oh, it's a tree of nodes, but that is kind of what it is. And if I look at parser AST, like here's my AST, and it's a bunch of different nodes representing grammar, and those all have pointers to each other, because if you don't do pointers, you get infinitely sized data structures. So you need like a little bit of indirection there to break your data structures not being infinitely sized, because they can potentially hold an infinite number of itself. Excuse me. Okay, let's see how fast we can break this. So load. Why did that explode? Oh, because this, maybe? Was split into load. Command error usage load command. Mm-hmm. Yeah, okay. So since this library that we're using is meant for parsing raw input from the console, it's bugging out because our arguments it's expecting that first argument. I'm gonna say if let some program name args push program into to string if we want to be specific. Who pinged me? I haven't gotten a ping from that server in forever. Okay. Okay, this one's OS string, so we're just going to keep this as into, and that will work fine. Now we can go down here. And just do that. To give it a program name, and then this should implicitly... Yeah, I know, it's a little bit messy to just have to have a placeholder string because the library isn't built for it, but I don't want to rewrite this library because the library does this very nice documentation stuff just from actual comments we put over stuff, so I'm not rewriting this library because honestly I don't care. Okay, we can get help. So if I say help exit, but help exit usage, BraneScript exit. Oh. So if it's going to be showing up in the help commands, I can just do here real fast. I'm going to say let prompt string equal since it's showing up in so many different places. Ah. Well, then I guess I'll remove the trailing space since I need to do a format string. Might as well just add the trailing thing there and not have a bug in my display. Was split into prompt string. Okay. That's actually what I want, is it to do that and not to give me a syntax error. That give me help now? Usage. BraneScript load options source. Well, this is a little bit messy. I think it's... yeah, it's fine. I wonder if we could do just an empty string. We do an empty string. It might look a little bit nicer. Usage, Brane CLI commands. Usage, exit. Okay, okay. There's 2 spaces here or just 1? Nice, no spaces. I should realize this is a print, not a print line. Okay, this is what I think I'm gonna stick with, because people don't expect... It's cleaner if we don't have the little prompt in here, but this is helping out the library because it's the format it expects of the program name as the first argument, and then all of that. So now let's actually test out, see if load works. Thank you. I will accept all the luck I can get. Okay, let's see. Right. What is this? Reprune, module default, removed mappings, shifted mappings, post prune, module default. That should have printed out like a fair amount of stuff here. What if we name the module test? Good. Pass module as a value, load source. Did I add module as an argument to load? No, I did name. but it still compiled it as module default. Do I pass in name? Do module name unwrap or default for calling, but not for loading? No, wait. I do unwrap or default here. You meant module namespace. Yeah, module URI. I think that's this user module here. Module default. So I guess that's not getting passed along somewhere. Load. If we do want to do like a full namespace sort of thing, then I do need to create a way to parse namespaces. So let's see, test BScript should have stuff in it for the printing to print. I mess with the emitter because I think it all uses the emitter. Well, actually, no. This here doesn't. So the module name being incorrect, I'm not a fan of. We need to fix that. So if we emit module, we parse module URI. Is it my URI? Self-loaded modules, insert module URI. Okay, so... Don't necessarily want loaded modules. What is... Okay, so this is compile context. This is our loaded modules. Ooh. I know how to solve this problem. The problem is that the URI... Oh, that's why it's empty. I'm not actually using my source code. Say into. There we go. Now my system is working as intended. There we go. While compare greater than not found. Okay. Do I have anywhere in here where I load in my default libraries? Actually, let's go to the compiler. Do intrinsics. So this is our standard library basically. And then where is we populate our intrinsics, and this is inside of... Okay. This is just when we run the compiler context. Got it. When we say emit module, we want to populate this with intrinsic functions. And one of these should be... Here's our signed compare. Greater equal, greater than. Okay. Interesting. Thought this was the code I was using to test stuff. But I guess It's not. No, wait. Greater than. Compare GT. 29? Test to be script examples, things. Test to be script. Oh, okay. I was in the wrong file. Well, line 29? Okay, 29. I think the loops were what I was trying first. Okay, let's see if runs. Failed to resolve path. This shouldn't have... That should not have crashed my... That shouldn't have crashed. I'm going to intentionally add in a syntax error. Because... that shouldn't have crashed my console. It's wrapped in this closure, meaning that is the rust backtrace. That's it. There we go. Now we actually get where it failed from. So it's coming from resolve template. From this anyhow error. But this is a handled error. Backtrace create. Okay. Error failed to resolve path. Correct error. Not found. Process didn't exit successfully. Ooh, shadow. Which one of the many shadow people is this shadow person? Because there's a lot of different shadow persons. Yes, we are VTuber mode this time. Because it's fun. Actually, my camera's like there-ish behind the monitor. so I can't look off to the side. Go away, VRChat menu. There we go. Really gonna look for... I was going to look... Dang it. Go main RS. This if statement here. So I was talking about Twitch chat with shadow people. The shadow people are giving me Minecraft facts. The voices. Well, yeah, so our error here was, so I made a closure so that I would be able to catch errors with the short circuit, like question mark syntax. So what this does is it immediately exits a function with an error value, basically. So it doesn't throw an error, but it like returns, this is the equivalent of if statement is error, return error, basically. Otherwise, just return the okay result. So this unwraps errors in a very, very clean manner. But I didn't want the unwrap to go directly to main because that kills our program. Instead, I want to be able to handle it and continue on with our day. The problem is, I was just using the short circuit operator on the closure meant to prevent the use of the short circuit operator. So we're going to say match on the result of this instead. Okay. We do okay, false, then do nothing. But if this is error, we just want to print and then the error, like so. The indentation is fine. At least I didn't keep the if statement there. There we go. Now our console isn't failing the instant something goes wrong, which is good. So let's open up this and fix the compare greater than real fast. Run it again. There we go. Now we actually have the module loaded and all of that. Now, what would be really fun is if instead of it just emitting all of this, if we could use the command line to print stuff out. Fun fact, passive pathfinding favors higher blocks to lower blocks. This is because the pink sheep yearn for the mines. I think I did see something about that, how you could build like pyramids and selectively put blocks underneath the pyramids or not to like kind of shift the probabilities of where mobs are, like if you're like building like a zoo or something. It is fun. Okay. So now we're gonna start removing. Why is it module default? This shouldn't be module default. This should be module the actual name we gave them. Actually, I didn't name it, but it should be lowercase default because that's the thing that we're passing in. Gotta mess with the headset because I don't have a custom head strap on this one, and it's a Quest Pro, which means my forehead is not going to be happy after I'm done streaming. It already isn't happy. It's worse than the Apple Vision Pro. The Apple Vision Pro was like pretty bad, but at least it was like bad, like spread over an area instead of a space on my forehead the size of 2 postage stamps. Rate the fun fact out of 9. So, as a game dev myself, it's a fun fact because you don't think about it. It's good game design. So I'd rate that like a solid 7 out of 10, fun fact. I guess I'll have to come up with the args for the for debugging the optimization stages, but our optimization stages are working just fine for now, so I'm not too worried about it. Oop. You know, I'm just gonna comment them out for now. I'm gonna say to do enable with flag. Is that all the printing out of that? Okay. Now we go here. Turning memoized enum. Why am I printing about returning enums? Structs. Okay, I think... Wait. Yeah, I think that's all of them. Okay. Load example scripts. Test B script. Name test. Okay, so we're still printing out assembly code. Okay, I guess since I don't have the files open... Oh, wait. Was that find string or find file? Find string. So something in here is still printing. The context emit module. Where is this? Oh, this is in here. Huh? Module. IR module new default. Aha! This is the thing that I want to change. This is a string or a stir? Come on, LSB, you can do it. Find me the definition. There you go. Okay, so it's just an into string. I did it fancy. Ah, no, this isn't an interpreter. It might look a little bit like the Python interactive prompt, but it's fully JIT compiled. You see this right here? That is assembly language. x86 assembly language. It can also do Arch 64 assembly language. Or ARM assembly language, I guess, is more specific, but... So let's try doing this again. I think it's still gonna print out the assembly language. Oh, no, wait. I just made it name the module correctly, not necessarily, Why is my editor? Okay. So we need to find out where it's going to print out the assembly language. Where do I do that from? So from emit module, oh, wait a second. It's not from here. Because the compiler is different from the backend. So it's emitting from here, this jit.jit. Come on. You can do it. Navigate. Fine. I'll do it myself. Not LVM. Train lift backend. Here we go. Why don't I have syntax highlighting here? Compilers. Okay, I'm just gonna save my workspace and restart Vim real fast. Because for some reason, it is being very slow. So I was there in the other streams, but however, how can you make a thing like the Python interpreter CLI while also compiling it? Wouldn't you have to restart the program? Also Linux. So the way I do it is you're not typing code directly into the CLI, you're doing like smaller commands, so it's going to be closer to something like GDB. It's going to be closer to GDB than actually compiling stuff. But the point of JIT compilation is that within the same program, that program can compile and then execute code without restarting. So that's like half the point of JIT compilation, is that the main use of JIT compilation is, I would probably say, in interpreted languages, where if they figure out that a function is running really hot, like that function is getting called very often with a similar set of arguments, it will JIT compile a native version of that function, and then in place of running the interpreter for that function, it will instead run the JIT compiled version. So that's how LuaJIT works. That's how basically every single JavaScript pipeline worth using works. But in this case, what we're doing is, instead of only JIT compiling the hot code paths, we're JIT compiling everything. And in this case, it is possible to load and run functions without restarting our command line. Like that, for the game engine I'm building, that is a required feature, is we need to be able to load code at runtime, but also unload code at runtime. And I would really like hot reloading code to work really well, because I've been coding Unity ECS stuff for the past couple of months, and it is a terrible, horrible developer experience. Like, would prefer to write engine from scratch than use Unity ECS, if I'm being completely honest. I like the ideas of Unity ECS. I don't like the interface you have to work with them. The next one. Does this do the disassembly? Yes, it does. Okay, so let's try running this again. Do we get any print statements? Any unwanted print statements? Let me specify. Been using dots with the ECS? Well, ECS is the data-oriented technology stack. Like, dots and Unity ECS are kind of the same thing. I know the data-oriented dots, the data-oriented technology stack, is kind of a more expansive, like the job system, which the job systems can be used without ECS in there. But yes, ECS is built. I kind of see them as the same thing. Like Unity dots is Unity ECS. Load. Example scripts test BScript. All right, now we need to add print statements so people know it worked. And it is, if they get the developer experience down, it is the next big thing for Unity development. Like, it's really cool what you can do with Unity ECS dots, but like, you basically have to build an engine from scratch. Like, you don't have to do rendering, but that's about the only thing you don't have to do manually. Well, I guess it takes care of input slightly, but the input is kind of managed, so it's like a little bit iffy. Where do you actually use like the new input system in there? Unity is quite the mudball, where there's a lot of cool things in Unity, but they all don't work together. So Unity has the old input system, the new input system. If you're using XR, you can directly connect to the XR inputs instead of the Unity inputs through input actions. So like, there's 3 different input systems to choose between. There's the old graphics system, the new graphics system, and if you're in the new graphics system, it's a scriptable render pipeline, so you can do whatever you want with it, but mainly you have the choice between URP or HDRP. So you have the old graphics system, the URP, or the HDRP to choose between. And now you have the choice on top of all of that. Do you want to be using Unity game objects, or do you want to be using Unity entities? Though Unity entities aren't built out enough that you can only use entities, so you still need to use game objects with your entities, but you're still going to be trying to use as much entities as possible, because, you know, game objects are slow and we need to be using Unity entities if we're using Unity entities at all. So that's like 3 different graphic systems you could choose, though I think in Unity 6 the old graphic system is deprecated and you can only use URP. So they are making strides in the right direction. But on most versions of Unity that like apps are built upon right now, there's 3 different graphic systems. You can choose 2 different input systems you could choose if you're lucky. If you're going the audio system route, you might choose an audio spatializer or use Fmod. So now you have to choose like which spatializer system you want to use, and yeah, which those options are good options to have. But like the graphics ones and the input systems are like, that's a lot of, yeah. Oh, hello, fellow engine developer. How are you doing? Sounds similar to how people talk about Windows when they don't like it as an OS. No, this is how I would talk about Linux if I didn't like Linux. Like, oh, I need to choose which desktop environment. Not even like, I don't have a desktop. We can choose GNOME, we can choose KDE Plasma, like... Linux is kind of the configurable unity in this case. How's the game engine dev going? It's been slightly slower than I want recently, because I've been mostly focusing on more job game dev related stuff. Depending on how things work, might work on it more, but I can't promise anything, of course. But in terms of like the scripting language, I'm like, I want to say, and of course the estimate is always wrong, I want to say I'm like 2 months of crunch away from the scripting language being usable as an embedded scripting language. Depending on how hard it is to do all the runtime stuff, because I have fully runnable functions being emitted by this, and they support structures, they support Rust-style discriminated unions like enums, and both of those are compliant with the C ABI. So like, I can write an extern function definition in Rust and like directly call the function pointer without any overhead. You're probably making more progress on an engine than I am with that approach, because you haven't been stuck on a scripting language for like 3-4 years. But hey, once I get the scripting language working, it's gonna be quite fire. It's gonna be real good once I get the scripting language working. Real good. Big plans. Big plans for this root vector. Big plans. Right, I was gonna add a print statement here. That's what I got sidetracked on. We need to go to main. It says 3 iterations later. Yep. Just adding things you think are cool. See, for me, I do have an end goal, and that end goal is I want to release this as a asset streaming engine, and I want it to be something that the studio I currently work at can use. Like, so that's kind of my goal, is get this to a point where I can be comfortable saying, hey Thrill, let's use this to make games, and I'm comfortable, like, it doesn't make the game worse, it makes the game the same as it would be on Unreal or Unity, or better. So at the moment, we're just trying to get to the point where like I could do like a VR chat room basically. Begone viewer bot. That's a pretty good goal, because I can look at like, what do we need to make games? And then once we get it to the point where I feel like it is ready, we can start using it as a team, and then we try to make something with it. We find that it's not ready in some aspect, and then that's what I work on. It's basically a web browser. It's not an entirely original concept. Oh, let's try real fast before I add this print statement in. Isn't the goal to also make it the fastest VR game engine? So, yes, caveat. The fastest game engine for user-generated content. It's going to be slower than a purpose-built engine for non-user-generated content, just by the nature of the beast. For streamed content, basically. Now, it might end up being the fastest VR game engine, but it's not the goal to just be the fastest VR game engine. I just think that the common ways that engines are being written are, well, or just games in general, like the performance of most social VR apps is just completely unacceptable. And I want to make them have acceptable performance. Like it's that simple. But where's the AI integration? There probably, so bear with me here. There probably will be some level of AI integrations, but it's not going to be like a little star icon in the corner and goes, "Hey, how can I help you today?" And you say, "Can you please do this?" And it goes, "No, I can't actually do this." No, I have ideas for how to make things actually useful. But I am not going to do anything that diminishes the value of the project or is forced. It's going to be like, can I do this and like have it actually be useful? Well, made the full swap to Linux these days? Based. But yes, I do game development. Unfortunately, the largest claim to fame is my team won a Horizon Worlds competition that had like a sizable payout, which was the main reason we did it. So we have a jank Horizon World published. It's cool though. We made like fully physics simulated cars. It does physics, the engine shifts, the gear ratios are all how gear ratios actually work. Actually simulates friction. I probably said that already. And we submitted that to a meta competition. Every single one of the categories we submitted to, we won something in. So that was fun. Got a little bit of funding for the studio. Isn't the main issue of social VR just unoptimized UGC? From the technical side, there needs to be a better platform for the UGC to be built upon. So it's not just that the user-generated content is unoptimized. Yes, there will always be an optimized user-generated content because the users don't know how to optimize their content. Like, most of them are 14-year-olds. Just, like, doing stuff they think is fun. And then, you have the few standout, like, people who are really good at it. And then I can't really make a judgment on the age of those people because it's genuinely all over the place. But my goal is for those with the skills to do it, you can basically make a fully featured game with the performance of a fully featured game. Not AAA game, that's kind of been sucking recently. Better than a AAA game. I want everything I write to be able to run without frame gen. That's like... the bar is so low. I just want everything to run without frame gen and hit the frame target. 90 FPS without frame gen. The bar is on the floor. Oh, right. Okay. We want to call... I didn't specify not module name, so we'll just use default. So we're going to call test function not found in default. What did I name it? Add test. Found function add test in the module default, but calling it is not implemented yet. Okay. So that is working. Cross-generational platforms. let's see, what is this in response to? Although even I could probably get that. Step 1 would even be, it's caring about performance along the entire path, basically. So there's kind of like the, is performance part of the end product or not? And in my opinion, it is, as much as like the art direction or the sound design. How well the game runs is like equally important as each one of those things. It's interesting because recently I played Expedition 33, and that game is very impressive in so many areas, but it's not technically impressive. Like, everything about that game was made with the features of Unreal Engine and like plugins to Unreal Engine. Like, they didn't write much of their own tech stack, and apparently like 80% of the game was blueprints. And like, that's kind of like, that's pretty cool to me, because like people can make a game and like they don't need to make it technically impressive. That's not how I would make a game, because I am interested in making things technically impressive, but it was like kind of a slap in the face to me a little bit. Like, okay, so what's your VR game design philosophy? I believe you should implement every sense to a certain extent. Say make it hand tracking first, make sure you have haptic suit implementation, etc. I haven't developed my VR game design philosophy to the point where I could really label any one thing. What I will say is I really loved the early days of like your Boneworks, your budget cuts, your games where you can open every single drawer and everything, like Half-Life Alyx. So those are the games that I'm personally trying to emulate, at least from an interaction game design side of things. I like when things feel real. They don't need to look real, but they need to feel real. And to a certain extent, sound real. Like, sound design, like, you take your headsets off and you feel you take your sound headset off while playing like an FPS and you feel blind. And I feel like sound design is incredibly important for VR as well, because like, if you can't see behind you but you can hear behind you, it's part of how you see the world. Wouldn't be hard to account for the future of how senses are handled. Don't know whether it is going to be done through some implant reading the nerves at some point. As cool as implants are, I'm not betting on them necessarily being safe within my lifetime. I think you could do output purely through implants in like 10 years. 10, 20 years, you know, your standard within our lifetime's estimate. I think you could do output, because it's, I don't want to say easy, but it's like, we've seen plenty of examples of, let's throw some electrodes on someone's brain and then map their output, like them telling their muscles to move, to the neurons that are actually causing that. That's, like, we've seen tons of examples of that. We can map neurons to telling muscles to move. The thing I don't necessarily see happening anytime reasonably soon, to a good degree, is input. Like, we're not going to get SAO where you put the headset on and then you feel like you're actually there. I'm much more invested in you're going to have a gimbal in your living room that costs as much as a car. And and it's going to be like an Iron Man suit and a gimbal. That's a force feedback haptic suit, like the Ready Player One experience, basically. I think that is entirely possible, and we will see that within our lifetimes, and I'm going to contribute to that happening within our lifetimes. Okay, what do I want to do next? I think for debugging purposes, at some point we're going to add in the ability to print. We're going to add in the ability to print out both intermediate representation and assembly code for modules and functions and all of that sort of stuff. I don't know if we're necessarily going to do that right now, because we don't need it at the moment. Right now I'm thinking I want to be able to call functions through the command line. That's kind of what I'm thinking. Oh, I'm not talking about the movie. I'm talking about the book, Ready Player One. Like, I have tried watching through the Ready Player One movie multiple times, and I have not made it through the complete movie yet. But I've reread the book several times all the way through. I love the book. Movie, doesn't live up to it. So with calling the function, there's potentially a lot of boilerplate we need to do here. So what I'm thinking about is, so first, when we call the function, we provide module function args. And then we can get pointer to function, and then call a function with arguments. Now, question for this: how do we get arguments? And then get return value from function. How do we get the function return values? And this is a pretty hard question. Because of the way that I wrote BraneScript, it's like, in a regular interpreted language, this would be pretty easy. It's just like, get the dynamic object, go through like, is this an int, is this a float, is this a string data type? But we're just like rojit compiling this, so we would get the raw function argument, but then how do we call the function and get the correct return value, especially if this is returning a structure? Like, the signature of a function is operating system dependent, and also operating system dependent, data structure dependent. Depending on the size of a structure, it can be passed in registers, it can be passed in memory, and all we have is a pointer. We can't really control the code that is around it unless we dynamically JIT compile another function to call our existing function. So that's something we could do, is literally just in here, go through the entire pipeline, JIT compile a function with a common definition that, like, we could have a common return type from our call logic. Or we could convert the, we could JIT compile code to, if a function is returning a structure by value, our common function could instead have that structure be returned by reference as a pointer. Because with a pointer, we can use reflection, we can read the intermediate code, figure out the description of the structure, and we can dynamically, like, print that out if we have a pointer to it. We just can't get by value structure returns. The way smell works might be kind of a particle system. Think more fluid dynamics, because air is a fluid. So in a sense a particle system, because fluids are kind of particle systems. But you're talking about, like, what you're kind of talking about there is simulating the flow of air in the room, I'm assuming. I don't think we can spare the compute for that. I think we'll just have smell volumes and then fade in and out of those. Agua. Okay. So I think the thing that makes the most sense here is dynamically compile a script that calls the function. Now, guess what feature we don't have that this requires? Module, this needs module to connect, or caller module needs to be able to link to the CLI module. And the caller module needs to be able, well, actually might need to be able to access something like runtime variables. Ooh, interesting idea. I'm gonna say this is option 1. Option 2. Don't dynamically, only dynamically call components, not functions. Components, only return memory referenced. Only return never by value. All components and queries. So if you guys weren't here for the last stream, I decided, I explained that I decided in advance that I am getting rid of the concept of pipelines in BraneScript. So in example scripts, somewhere here, is this it? No. Do I have an example of what pipelines would look like? Anyways, if you've ever used a coroutine, the concept of a function that yields control back over to the runtime at certain points in the program, or if you've used async await in JavaScript, it was kind of a differently formatted version of that where there's like hard boundaries, and you put as many awaitable variables into those boundaries, and that's how you interact with the runtime, is in synchronous segments that, in those synchronous segments, they're like pure functions. And that's like theoretically a very easy thing to multi-thread. But I was like really struggling with how I want to coordinate and schedule all of these pipelines together and how it's going to interact with the game engine. And I came up with this idea of a component graph system for the engine, and I was uncertain on if I wanted that to be part of the engine or part of the scripting language. And I decided that I wanted to be part of the scripting language. And I wasn't sure how pipelines would interact with components. So I figured out that with the way that components work, components being both a couple of data structures and a function that updates the state of a component. So components have to declare what other components they rely on. So like what data they require to do their update. It's basically like a query graph. A query graph is comprised of components. And I can statically or dynamically validate that query graph is valid and doesn't have any circular references. Yeah. So basically, I decided this query graph is capable of replacing pipelines. It does make stuff like I/O a little bit more complicated. We're going to have to do something a little bit weird like runtime defined buffer components, where other components can rely on the value of this input buffer, essentially. And that's how, instead of awaiting like input values, you'll instead read from the buffer of inputs. So there will just be a buffer that's always listening to inputs, and if you need that, you just declare that as one of the requirements of the component. Yeah. So that's going to be how more so how BraneScript works now. But it means that we're going to be able to compose pre-scheduled queries. So instead of our job scheduling system just trying to work on the fly, instead of our job system just like working on the fly, as like pipelines are just firing off more work for it to do, instead we can have a query. We already can see the structure of the query and work with that to schedule stuff. So I think this is going to be an incredibly solid system. And we'll basically build the game engine on top of the BraneScript runtime instead of the BraneScript runtime being embedded into the engine runtime. It's kind of what I've decided at this point. Anyways, now that you know what components are, this option 2 of only dynamically calling components and queries, not functions, works because the way the components work is they're only run once. They can cache values, and they only return values as in-memory pages, because we'll want to be able to share the memory of the components to the components that depend on their values. So that's a lot easier to dynamically read the memory of those structures with reflection, with runtime reflection, basically. Because our intermediate representation stores all of the metadata about the layout of data structures and what functions return, and by extension, what components are comprised of, I think we do need to put components into our intermediate representation now as well, to handle all of that. But this will be very... The only thing we can query is queries. No, I don't want to have... I want to be able to dynamically construct queries from the CLI, possibly even write components from the CLI. But it makes sense to not necessarily... I think we can add in the ability to call functions later by dynamically creating a component and then calling it. But this is like potentially easier. But what this needs components. Needs components to be implemented in grammar, IR, compiler, in the grammar, in the compiler, IR, and runtime. This also needs page allocators. Page allocators and bindings to be working in the actual runtime itself. Alright, let me read chat for a moment, because I have been neglecting. I've heard reports of, like, the absolute newest models that cost, like, the ones with the subscription that cost hundreds of dollars, one-shotting writing scripting languages. I don't know if you can do anything with them from there, but I know people who have pulled it off. Bold of you to... Bold of you to assume I've already processed what you said. This is true. the sides of this headset pressed on my forehead more. Interesting. There's like pieces of plastic that make their way back from the halves of this. Does that mean I can tighten just that portion of the head strap and mold it to my forehead? 1 second. Feeling it on my head, and yeah, that does look like an adjustment strap. Now, how do I adjust the adjustment strap? Oh, wait a second. Okay. It's not the external plastic that tightens, it's the internal plastic ring that tightens. So this little ring... Interesting. So, counterintuitively, if I tighten the headset more, it might decrease the strain on my forehead. Let's give it a go. Oh wait, I forgot to put the back head strap, or back head cushion on there. That was about to be much more uncomfortable headset. See, it's been a while since I last saw one of your streams. I think you were working on Node something last time I was watching. Node. Like the JavaScript runtime node? That would have been a long time ago. Unless you're talking about node graphs, which would have been about 6 months ago. Which headset are you using right now? I'm using a Quest Pro at the moment, which is why I have the face tracking and stuff. Basically, for the game studio I'm working at, the Quest Pro is our, like, it's our test headset. It's old enough that, like, if it runs on a Quest Pro, it probably runs on everything. And it's like, yeah, it's kind of a good test bed headset, because it has like eye tracking, face tracking, all that stuff. So you can experiment with stuff. Eye tracking is wigging out, and like Steam. There you go, Steam Link. You settle down. Okay, we're not good. Okay, yeah, that would have been roughly 6 months ago, like about the time I was going to AWE. Okay. Okay, yeah. Quest Link is settling down. Back to planning. Only dynamically call components and queries, not functions, components. Oh no. To get my scripting language working, I'm gonna have to get my scripting language working. Page allocators are scary. Because, so for the bindings, For the bindings, bindings are separate per execution context, because by disconnecting a binding, you are able to, by setting a binding to null, you're essentially able to say, like, you're not able to access that page from this execution context. But the thing is, we don't necessarily have to bind pages to specific bindings, but changing the binding changes the pointer signature. So if you want your pointers in data structures to stay consistent, you basically need to walk over the data structure and reconstruct its pointers every time anything it points to switches which binding the memory page connects to. So I'm going to try to avoid all that and keep bindings consistent, since components are going to be sending pages to and from each other pretty consistently here. But what this means is that our bindings, at least for the bindings that we know we're going to share between threads. For temporary bindings, it doesn't matter. We can bind those wherever, and they die after we're done dealing with a component's update. The problem is we don't know what is temporary until the component finishes, because the component might store data structures requiring pointers and dynamic allocation inside of them, which means we would need to keep originally temporary pages alive. So So basically, it makes sense to make sure that all memory page bindings, are unique to start off. Which means, unfortunately, I can't just let I'm trying to avoid thread communication as much as possible and only have them send data from each other. And everywhere I can remove an interface where threads talk to each other, the better. For this, I guess I do need to make the threads talk to each other, unfortunately. So we do need to have a central page allocator, and I don't necessarily think we need a central page pool, but we need a central page pool. And if I'm going off of my, let's just get this working first and then optimize it later, yeah, we need a central page pool, unfortunately. So part of the BraneScript runtime is going to be a page allocator, which has not allocated. So what we could do is just allocate 4 gigabytes of RAM immediately. I am a little bit disappointed though, because one of the original reasons it came up with the binding system is to avoid a 4 gigabyte of RAM limit on all possible memory in use by the scripting language at any one time. I wanted I wanted to avoid that limit by the bindings, because, like, with this, I could still use 32-bit pointers, which 32-bit pointers are easier to sandbox, because the top 16 bits are the like the binding address, and the bottom 16 bits are the actual page of memory. The problem is that if you have a larger pointer, like a 64-bit pointer, now you have to split it in. With 16 bits, the reason it's fast is because I can just allocate a bindings array per thread, and it's like reasonable to do that. It doesn't take much memory to do that. Like it's like not a small chunk of memory, but it's not a noticeable chunk of memory, and it's like one per thread. So like 64 maximum if you have like a older Threadripper, or I don't know, newer Threadrippers might have more. And then those bindings, you don't have to runtime check them. You don't have to do a branching check on them. You can just mathematically ensure that your pointers never go out of bounds. And I thought, okay, 32-bit pointers, because we can just mathematically ensure that it's not possible for them to go out of bounds. But if we need more memory, we can just say this thread, this same exact binding on this thread is not exposed to this thread over here, but the same binding on this thread is bound to other memory. So a pointer in this thread would actually be completely invalid in a different thread, because it would be pointing to different memory. But that would allow us to allocate, then the limit would just be 4 gigs per thread instead of 4 gigs in the entire system, because I'm thinking at some point, like, if you're doing an open world game, you might exceed 4 gigs of memory total in your system, right? And that might be possible to still pull off, but I don't want to solve the problem by switching to 64-bit pointers, because then, yeah, you just have the pointer, like, every single memory access becomes less efficient once you switch to 64-bit pointers instead of 32. Like, every single time you dereference or reference a pointer, it takes longer, because you have to do like 3 ASM commands instead of 1 already. It would turn to like 5, 6, 7, something like that. So it'd be a lot harder with 64-bit pointers. I think for now, I'm going to accept the 4 gig limit, because reasonably, if we're careful about only putting textures into the scripting system when it needs textures, would texture lookups be async? I guess maybe. Or, yeah, we'll just accept the memory limit for now, and I think I'll be able to figure out a way around it in the future, maybe. And that might require, like, that might need something to do with requiring copy constructors for every single data type. Like, if we try to return data on a page that's in a binding that's reserved somewhere else, like if we try to bind 2 pages on the same binding, then we just call the required copy constructor for that type and copy it over to another page. And that would fix the problem. It'd be a little bit of extra overhead, like just shuffling stuff around in the back end, but that would fix the problem of memory overuse. So for simplicity now, and to avoid needing to do fancy metaprogramming stuff, or adding fancy metaprogramming stuff to the program, because I don't want to have to manually define a function for every single type to copy them, or shift their memory. Yeah, okay. So I guess first things first, the thing that I've been really putting off, let's make an allocator. So this is our bindings context. This is what we pass to functions at the moment. I think this needs to be an execution context instead. And we need to start working on having an actual runtime. So the bindings context is now going to become an execution context. So we'll have one of these per thread, basically. I don't think the page binding map that won't be necessary for now. So then these pages are actual pages. Allocation from our OS level page allocator. Yeah, this binding error, we're gonna move over to runtime. as well. Let's throw it above the implementation where it gets used, out of habit. I don't want to get rid of this code actions. There we go. So I think we do need the difference between shared pages and owned pages. Not quite sure what the shared pages are going to look like quite yet. One ping from the Rust XR server. I really want to do some mobile graphics chip stuff, because I really think there's mobile graphics stuff that's possible that people just aren't doing. Like, guys, transparency isn't bad on Quest. Unity is just bad at using mobile graphics cards. That's my opinion. I have reasons to back it up. It's getting better at it. The absolute latest releases of Unity 6 finally are starting to have subpath support to actually do stuff the correct way. With Vulkan subpaths stuff. Come on. Use standard sync art. Atomic reference counted? Does that do it? Does. Okay. My code actions working. So I'm not doing range-based mutability anymore. So I'm just going to delete that. Now, since I'm also doing... Yeah, I'm just going to delete all the management functions for the moment. And we're going to write... What do we want to call the main runtime of BraneScript itself? What do we call this? We do script engine, virtual machine, straight up context. I don't like just doing straight context. Brain context is a little bit too vague because this might eventually, well, no, not might. This will eventually be used in the engine itself. So brain context is too vague. Script context. It's not even scripting. It's compiled. Main brain. Main brain could work. Think. For Lua is just context, right? Lua, new state. Yeah, it's, okay, so it's not context, it's state. So when we embed C# as a scripting language, mono is just mono. If we embed core CLR in our C++ application, why do they have this huge sidebar here? DL open, core CLR, DLylib. That's a Rust thing, isn't it, to call it DLylib? Or is it just a Linux thing? Core CLR init app path host sizeof. I guess they just call it core CLR. Got it. We'll just call it runtime for now. I think Rust lets you alias stuff, so I'd be able to do it as like BraneScript runtime. Okay, what is going to be in our runtime? Page pool, of course. And that's going to be from memory. And this is what's going to manage all of our memory. And so when I'm thinking allocator, I'm thinking of two different allocators. There's the allocator of pages, and then there's an allocator that should work within pages, because if we don't have a within page allocator, then we run into the issue of a page allocation per struct allocation, which would yeah, that would not be efficient. Okay. Page pool, and let's see, we're gonna have we have page table, and then we have, where do we have page? BraneScript page ID 264. Somehow we allocated vastly more pages than there are grains of sand on Earth during the execution of this program. I don't know what I was doing with the memory handle stuff. Page ID or a page vector. Okay, I kind of see what I was doing here. I was thinking because I'm gonna solve this problem when I need to. It's just BS pointer. Actually, it is, because if we have all of our pointers... Right, that was when I was thinking about a different memory management model. Where you would asynchronously await on, like, actually getting memory. Which would be slow, very slow. But I considered it, but it was very slow. I'm gonna remove pool because we already have store. Which, keeping with our blatant ripping off of WebAssembly, I think we should keep up with it. So we have memory store. Before our runtime, we also have a memory store. Do I have a new for store? I do. In the store. Need this to be an atomic U16. See, this is where, like, I start thinking too much about future optimizations, because instead of having one mutex locked vector of unused pages, instead we could have thread local pools of unused pages, and then there'd be a little bit of buffering between the thread local pool and a global pool, to where before needing to interact with any other threads, they would just check the thread local pool of pages, and if there's nothing in there, then they would go to the unused page pool, like global unused page pool. Like, it would get buffered, basically. It's like having caches of memory pages to not have to do syncing of stuff. Do I need to store shared pages here? I don't think I do. I'm just gonna do a we're just gonna do a vector of pages, and this is gonna have a read-write lock. No, we're not gonna derive default. We're gonna start our counting at 1 because we want page ID 0 to be null pointer. Oh wait, we increment the page ID before checking if we have unused pages. Alright, because page IDs were going to be unique per allocation before. Not anymore. We get our ID, we get our data. Okay, instead of having a page ID counter for now, we're going to use the length of pages as our ID counter. Do this allocation before we lock, so our lock is as short as possible. Ooh. And we don't have to do -1 because we actually want it to be +1. Allocation error. ID is going to be if ID is equal to U16 maxed, then you return error. Allocation error out of memory. Location owning. Location might be owning. Okay. Pages. This is an owned data structure. Which means we actually do need to revert this. Don't want to revert it fully. I'm gonna make it slightly larger, that way we can just... We're sure that we can detect this overflow value. Atomic A16. Okay, now we know for sure that we never use pages. Or did I just say now we know that we never use pages? Of course we use pages. What am I talking about? We say okay over and over again, and it doesn't make it so. Don't want execution context to be typed. Tightening the Quest Pro does not help with this comfort. Excuse me. Okay. Let's actually initialize a runtime. Okay, and I think the compile context. I think we want our compile context and runtime to be the only two things that the command line works with, because those are the two things that we want to be developing with the command line. So having any behavior be unique to the abilities of the command line is not what we want to do. Okay, yeah, we will continue building this to have... So we could have different JIT backends in the future if we want to. To implement JIT backend or crane lift JIT backend. We're also going to make JIT backend require default. Alright. So I have a lot of boilerplate ahead of me before anything interesting happens. And this headset's pretty uncomfortable. So I think I'm going to cut the stream there. Lots of good work, lots of good planning done so far. I am going to keep working on this off stream for a couple hours here. After I grab some food. And I will post any updates in the Discord if anything interesting happens. I don't think I'll get to the point where, like, I'm actually calling stuff, but I don't know. Maybe it will happen. Though I do hope to get that moment on stream when it actually does. Alright. Well, this has been a very good stream. So, yeah. Hope everybody